Come on out. Welcome back. We're in our last session. Thank you for being here. And you have to stand here.
All right.
So everyone, this is Glenn Wagren from the University of Cincinnati and the director of the Center for Business Analytics.
That's right. That's right.
So tell us what the Center for Business Analytics is.
Well, it was set up 8 years ago as the outreach from the academic department at the Lindner School of Business in Analytics to the business community. And it's a program the program itself is almost 40 years old. And this year we were ranked #1 in Masters in Data Science program from Predictive Analytics Today. And we have 25 companies that are part of the center. And a lot of what we do is we put our bright graduate students, which almost are 100 right now, to work on meaningful projects for businesses throughout the business community, and includes companies like Macy's, Procter & Gamble, Great American Insurance, the Cincinnati Reds. Lord knows they need the help.
We might be Tribe fans. Who's a Tribe? Anyone? Sorry. So tell us about your role with the competition and how that came to be.
Well, we came up last year, and we were just thrilled with the program in Women in Analytics program, and we wanted to take a stand-up participation in the program, and so we offered to sponsor the visualization contest this year, and so we started with a field of 56 entrants, and then a combination of faculty and staff from UC reviewed those and down-selected from 56 to 10 entrants. And then I believe over the course of the last several weeks, the community voted on those 10 and down-selected to 5 entrants. And during the course of today, through the app, you all voted for the winners. And we're going to announce.
Let's bring the winners out. Come on out,
let's
ladies and gentlemen. Ladies and gentlemen. We have 4. We have 5. Come on out when you step over here.
Oop.
I hope you guys all had a chance to look at them. They were spectacular. So Glenn's going to go ahead and take over this part, and we're just going to give the awards when you're ready.
All right, very good. Well, let me just first introduce you to all 5 of the candidates here, if you haven't had an opportunity to meet them. First, Kim Lee Scott for Water and Gender Equity. Why don't you raise your hand there so everybody knows? And then
No.
Kevin Flerlange, drunk driving. Michelle Mirage on Nellie Bly. Amanda Lopez for Women as Leaders. And finally, Kuhu Gupta on Impatient List. Okay, so there are three awards, and the prizes for those awards are $1,000 for first place, $750 for second place, and $500 for third place. So, drum roll. Nice. Okay, third place for Women as Leaders, Amanda Lopez.
Woohoo!
And here you go. Congratulations. Second place, drum roll.
Oh, come on.
Kim Lee Scott for Water and Gender Equity. There you go. Congratulations. And finally, drum roll, Kuhu Gupta for Impatient List. Very good. Congratulations. Let's give a round of applause for all of the finalists and everyone who participated in it this year.
Thank you all. Congratulations, because that was an award getting to this stage, and thank you to the University of Cincinnati for sponsoring us. One more round of applause for everyone, please. Thank you.
Very good.
You guys can come on up.
That's right.
Okay.
Congratulations.
We have one more quick announcement to make before our final speaker. And for those of you who were in the raffle, I have the awards for the raffle. So unfortunately, I don't know where the raffle prizes are, but they're back. So I do know where they are. They're back at the table, back there in the text. So if I announce your name, please go visit them at the end of the session. So the sponsor, I'm sorry, I don't know how to say this, Avande, is that right? Help me out, someone. I didn't get to. Avanad, thank you. Sorry I didn't do my spell checks before I came out. The winner is Arianda Martinez Gonzalez, and you won the Bose SoundLink Micros. Congratulations, Arianda. Illumination Works, sponsor, thank you, Illumination Works. The winner was Susan Chapman for a $100 Amazon gift card. Congratulations, Susan. Another sponsorship from the University of Cincinnati, and there are many winners. I'm going to name one of them. Abigail Steese and your crew won a free pass to the Analytics Summit 2019 on 4/3 in Cincinnati, which Glenn wanted to announce there is an Analytics Summit. It's case use, best case use studies. It's supposed to be interesting. Make sure you check it out. But I'm not sure how you're going to split the pass. I'll let you guys figure that one out. KeyBank sponsored one. Thank you, KeyBank. To Anita McSwain-Williams, you got 4 Cleveland Indians tickets. Go Tribe. And the last one is the Huntington National Bank. The winner is Emily Allen. You won a CanaKit Raspberry Pi 3 Model B Complete Starter Kit. Congratulations, Emily. I think that's it. That was fun. All right, on to our last. For those of you who weren't in this room before, I will reintroduce Katie Sasso from the Columbus Laboratory, one of the very important key core team members for WIA, to introduce our last keynote speaker for the day. Please help me welcome Katie Sasso.
All right, so for those of you who don't know about our next presenter is going to help change that a little bit. Her name is Amanda Gadrow, and we are so lucky to have her today with us. I met Amanda through Our Ladies Columbus, which is a meetup here in town that everybody is welcome to attend. You can check us out online. And Amanda is a software engineer with many years of experience writing automated test frameworks for enterprise software. She's currently the head of QA and support teams at RStudio. She started learning R when she joined RStudio back in 2016, and she's been loving it ever since. She spends a significant amount of time analyzing customer data to improve their products and optimize support. Amanda is an expert on software and all things R, so I'm looking forward to having you guys learn and enjoy her talk. So please, without further ado, let's welcome Amanda Gadrow.
Thank you. Good afternoon. I'm excited to be talking to you today about a topic that is near and dear to my heart. I am the Director of Quality Assurance and Support at RStudio, but I'm also a software engineer turned data scientist. So today I'm going to talk to you not only about what we did, but why we did it, and how we're using it to drive some of the significant growth that we've seen in the past couple of years. And it also, I want to show you how you can use the same techniques to effect change within your own organization using data that you already have. So when I joined RStudio 3 years ago, we had a problem. No one really knew very much about how our commercial products were being used, and we didn't necessarily know where our customers might be struggling. And we wanted this information for several reasons. We obviously wanted to make sure that our customers had the best experience possible. We also wanted to foster customer loyalty by making the products as easy to use as possible. We wanted to establish and share best practices and teach them to our users. We wanted to enable them to expand their usage of our products. And we wanted to promote the R language and community by building the best tools possible using that R language. To do all that, we needed to understand where people were getting hung up so that we could then remove those roadblocks for them. And we were collecting data in the form of support tickets and sales information, but we weren't doing anything with it. We weren't aggregating that data to try to figure out how our customers were using it, where they might be struggling, and how we could make a better experience for them. We didn't have a really good idea of how we could improve the products to meet our goals that I had stated earlier because we didn't have any visibility into that data. So to give you a little bit of a background of our company, RStudio is a small software company based in Boston that builds tools around the R language. We have a mission to provide the most widely used open source and enterprise products built around that R statistical computing language. These tools further the cause of equipping everyone, regardless of means, to participate in a global economy that is increasingly data-driven. And our goal is to empower users to be productive with R. To accomplish that goal, we invest quite a large proportion of our resources into open source tools. 57% of our company is engineering, and 56% of that is open source. So they're working on open source assets that we make available for free to everybody in the world if they want it. Our core mission is essentially to make R better so more people can get value out of their own data. We're committed to promoting the inclusive community that surrounds R as well, so we spend a lot of time in that community promoting the language, letting people know that they can have this stuff for free and they can actually use it in a very productive way within their own companies. As we've been working towards this goal, we've learned quite a bit about our users based on some of the work that we've done with our own tools. When we started this project, we knew quite a bit about what our open source community members thought, because they were pleasantly vocal in our community forum and also in issues they were filing in our GitHub repositories. Everyone in our company has free and open access to this information, and we did not have to worry about people sharing their opinions with us in these forums. This was not a problem we had. The problem that we did have is that we knew far less about what our commercial product users were doing with the products and any of the problems that they were coming up against, because their issues were obscured behind the third-party tools we were using to track that information. There was no good way to aggregate the data. Those tools are excellent for solving the immediate problem that someone was having, but less so for being able to get at that data, aggregate it, figure out where we were having trends that were problems that we needed to solve. So we were collecting user feedback. We were storing it in disparate data sources, and then essentially we were letting it fall into a black hole. Except we weren't really letting it fall into a black hole, we were just using it inconsistently. So our support engineers were really good about noticing trends and bringing it to the attention of the people who could fix the problems. And our development teams are excellent. They were and are excellent at taking a look at the trends in the customer service tickets and also in the information that was coming in through sales and sort of integrating fixes and resolutions and changes into the products themselves based on that feedback. But we weren't doing it in an organized and strategic way. So lots of things were falling through the cracks, and we had no idea what those things were. We reacted well, but the truth was that nothing we did was repeatable, and we had no way of measuring whether the changes we were making were actually having the intended effect. What we needed was a way to analyze the data such that it was reproducible, so we could run the same analysis, or your colleague could run the same analysis and get the same results. We needed it to be scalable, so as the business grows, the analysis could grow with it, and it could expand based on greater data, different data set entirely if it needed to be, changes in the stakeholders, changes in the types of issues that were coming in once we were a larger company. And we also needed this to be measurable, so we needed to be able to tell whether the changes that we're making were materially improving the lives of the people who were trying to use these products. Until then, we didn't have an organized way to get meaningful, actionable information out of this data, so we couldn't make business decisions based on it because we had no way of looking at it at that point. So we decided to take our own advice, and we built a tool to do exactly that. The data we have comes from multiple sources. We use Zendesk for our customer ticket information, Salesforce for our customer account information, Marketo for our customer communication data, and LimeLM for our licensing information. So when people buy a server from us, we're able to tell whether or not they've turned their license on, essentially. There was no good way to bring all these data together natively, so we built one ourselves by importing the data into R. We used the application programming interfaces, the APIs of these tools, to be able to bring all this information into one place. Once we got the data into R, we were able to do wonderful things with it, actually, by putting it through our data science toolchain to explore, analyze, model, visualize, and communicate the results of that back to our stakeholders. This is how we view data science, as a continuous improvement loop, basically. So once you get the data in, you import it, and you tidy it up so that it's in the kind of shape that you can actually use it. And then you go through a cycle of transformation, visualization, and modeling until you have a good understanding of that data that you think you can get some business insights out of. And at that point, you're able to communicate it to your stakeholders to make any decisions based on that data. Once the data is in R, it's relatively easy to build scripts and applications that allow you to run analyses and communicate the results. Interactive, shiny applications are great for discovering meaningful trends in the data. User controls allow people to explore the data based on the values of parameters and filters. This is just an example application using financial data, but when we use similar techniques on our own customer data, we found some really interesting things. For example, when we took a look at our customer support ticket data, we found that the bulk of our tickets were filed in the afternoon, Eastern Time. This was actually a surprise to us. We thought they were all coming in the morning, just from the way it felt when we were going through the tickets. But in fact, they were being filed the afternoon before, and then we'd have to deal with them in the morning. We didn't know this until we ran the analysis, and once we ran the analysis, we made the easy decision that the next 2 support engineers that we hired in the Mountain and Pacific time ranges so that customers had a much faster response time. This is awesome. It's actually driven our response times way, way down, and so people, just by that decision, have been having a better experience with us when they come into us with a problem. We've also built applications to help us understand complicated data from multiple sources. This is an application that we've built that pulls data from the support ticketing system, the sales information database, and our licensing vendor. And we're using it to try to identify some risks, such as low net promoter score, underutilized licenses, and a large number of support tickets. This helps us identify accounts that our customer success representatives can then reach out to, talk to, and basically intervene and say, hey, how can we help you be successful with our products? We've noticed that you've gone silent, or we've noticed that you've filed a bunch of tickets. Is there something we can do to help you out? You can filter this data. It's a shiny application. You can filter this data based on a variety of filters, such as how low the NPS score has to be for the threshold of risk, and whether or not to include accounts who have never filed a support ticket. Maybe they're actually happy. You don't know until you look into the data. In another report, my colleague Andre de Vries took some of this same data and built a model to predict customer churn based on the RFM method for analyzing customer value. RFM is an initialism for recency, frequency, and money, and it's a method for aggregating sales data into a single number that attempts to identify high-value customers. In this model, we're looking at the confluence of our sales data on the x-axis and our support ticket data on the y-axis to try to identify customers who have churned so that we can use this model on new customer data and try to predict whether or not they are not going to renew their licenses. And at that point, we can reach out to them very early in the process to make sure that they're getting the value that they expected from their licenses of our software. This model is instrumental to that effort, and he built it with entirely open source tools. The importance of visualization cannot be overstated when the goal is to effect change in your product organization. So I'm fortunate enough to work at a company where the value of data and good methods for working with it are well understood, but nothing beats a pretty picture backed by meaningful data if you want somebody to change something for you. This dashboard we built to explore trends in the ticket data. Based on the date, the product, and various filters. This tab talks about how many tickets we have. It's a volume indicator. But there are other tabs over here for who is filing the tickets, why they were filing it, and when they filed it. And this can drive our decisions around targeting types of customers. Perhaps a particular industry is having the same problem with a part of our product. Or somebody's having trouble with a feature, and we've noticed that we've had 16 other tickets on the same topic. Maybe we should look into how that feature is being built or used. And then on the when side, I already shown you the graph, we decided to change our hiring practices based on when people were actually filing the tickets. Once we've done some data analysis, we now need a good way to communicate the results of that analysis out to the stakeholders to make sure that the right people get their eyes on it. We need to get this into the hands of the people who can use it in meaningful ways. So in this example, this is a shiny dashboard that we created to visualize the results of our user survey after our 2019 RStudio conference. Excuse me. It automatically pulls the most recent data and presents it in an R Markdown document, which is deployed to a Connect server to which all of my colleagues have access. So anyone can log into the server and see this, and potentially see the latest information and maybe make decisions based on what they're seeing here. For example, this map from the same application allows you to drill into the different areas of where people were coming from, both in terms of the people who physically came to the conference and the people who called it or who were watching the live stream. And we're actively using this map to decide where we're going to take our roadshow this year. So where are we going to go to promote R, potentially spread those best practices I was talking about earlier, and go to meetups to promote the R language itself and encourage people to try this out. These applications and reports are freely available to whomever at RStudio chooses to log into the server and view them. However, sometimes I want to be a little bit more proactive about disseminating this data. So instead of waiting for our stakeholders to come to the dashboard, I want to send the information to this. And for this, I use RStudio Connect to schedule an update to an R Markdown document and email it to my colleagues with the latest data. You can also create parameterized reports that are rendered based on user input. And you can even decide which data to process depending on who's actually looking at the application. This is just an example of some stock market information, but we have a similar application within our own organization that takes a look at customer data and attempts to identify accounts who have missed calls. And our customer success representatives take a look at that data, filter it by their own accounts, and are able to then reach out to those people and say, hey, I noticed that we've had a hard time getting a hold of you. Is there anything I can do to help you? In addition, you can use this in conjunction with a scheduler to actually create a parameterized report and then email it out to specific stakeholders. This is really, really powerful because it means that you can take your data, filter it, slice it, and dice it down to kind of segments of people that you need to see that data, send it out to them, and they get the targeted information that they're able to make actual business decisions on because they're seeing the stuff that is most meaningful to them. Finally, in addition to keeping our teams informed about how the product's being used, we also use these reports to identify trends in the customer data and find areas where people are having the most trouble. We take that data and update the documentation if we have found that people aren't finding it or that our documentation is not as good as it could be in terms of explaining how to use features. And we also file issues with our development team so that they can make fixes and changes based on how people are actually using the product. We then follow up with those teams to make sure that these changes get interleaved with their current work so that they can make improvements and they get visibility into how people are using it. And this often inspires them to think more carefully the next time they're designing a feature to make sure that it's going to handle a lot of the scenarios that are coming in from the field. Some examples of improvements that we've made based on the data analysis we've done with our customer data are the ability to change the authentication method on a server, the ability to customize those emails that come out of the server when you're proactively notifying somebody that a change has happened in the data. Better user feedback when people make common mistakes. Our errors are better now. And a new diagnostic tool so people can troubleshoot issues as they happen, so they don't even have to contact us. It's not that we don't love them, we're always happy to talk to them. But if they can diagnose their issues more easily and more quickly, then they're happier and we're happier and everybody wins. In addition to that, we've made a lot of UI changes into the user interface to make it a lot more intuitive and easy to use as well. All this was done in response to user feedback that we deliberately analyzed and deliberately drove some product improvements from this data. In addition to changes in the product itself, we've also implemented documentation improvements, clarifications, examples, cross-references, things like that, and optimized many of our support processes. I've already mentioned how it has changed our hiring plan, but we've also created new templates for support ticket responses based on the kinds of issues that we're seeing people file. We've also implemented better escalation procedures based on the type of ticket that comes in, so we're now targeting the people who get that escalation in a way that makes it a lot faster for the user to get some feedback. And we've also implemented Linux training for our support engineers once we figured out that a lot of the tickets that were coming in were actually environment diagnostic issues, not necessarily R or RStudio, but the environment on which the server was installed. That training allows our support engineers to respond much more quickly because they have better knowledge under their belt. And finally, we've introduced some transparency into these tickets, into the licensing as well for our customer success representatives that they can then use as context as they're interacting with our customers on a regular basis and foster customer satisfaction and loyalty. To measure the effectiveness of our changes, we go back to the original analysis. Remember that it is reproducible, so we can rerun the reports easily to see if our enhancements produce the kind of reaction that we wanted. So in this example, in the top graph here, we were noticing that there's an increase in the number of tickets that were coming in for offline licensing. So our enterprise servers can be installed on a Linux server, and we require an internet connection so that the server can then talk to our licensed server to validate itself on a regular basis. It is, however, possible to activate your license in offline mode if your machine does not have an internet connection. But the problem was, while the process was straightforward, it still required manual intervention from our support engineers. And so people were not only having to talk to us, but they were having to wait for us to get back to them. Once we'd identified this trend in the analysis, we decided that we needed to build a customer-facing application to allow people to do this for themselves. And it would be a much faster response time for them and much less work for our support engineers, and they could concentrate their efforts in other ways. So in this top graph here, the red line shows where we implemented that app. We created the app, we linked it into our documentation, and we almost immediately saw a decrease in the number of tickets. You'll notice it didn't go all the way to 0 because people tend to ask us before they look at the documentation sometimes. But it did mean that our tickets were much shorter, right? The longevity was much smaller because we had a really easy answer. All we had to do is say, hey, you can use this app to activate in offline mode, and you're off to the races. The bottom graph across here is a Google Analytics chart that shows the usage of that that custom app that we built. So we can see here that it's getting pretty consistent usage, so we can tell that people are finding it and using it and getting an instant activation for themselves without having to wait for us. Measuring the success of the changes we made based on the results of our analysis is really important because we want to make sure that the changes that we have implemented materially improve the lives of the people who are using the software. So to gauge success, we check a couple of things. First, we rerun the analysis, as I mentioned. That allows us to tell whether or not the trend's going back down after we made a change. We look at the number of support tickets that are filed for a particular feature that we've recently enhanced. We like to see that going down, meaning that people are having fewer problems with that particular feature. We look at the longevity of the tickets as well to make sure that when people do write in, the responses are not only quick, but also the resolution is quick. So it's really easy to solve a ticket by saying, hey, look at our documentation, it tells you exactly how to do it. Or, you know what, we just fixed that in the last release, why don't you go ahead and update the software? Those are very short tickets, and we love short tickets. We also look at Google Analytics to see if our documentation and our custom tools are being used. And we can do sentiment analysis to take a look at how people are reacting to new features and new releases. So we look at our social media footprint and see whether people are happy or sad with the new stuff that we've released. And finally, we look at our Net Promoter Score and other information coming in from the sales field. Are people happy with the way it's working? Are they happy when we fix something that they reported? That we can get from the sales organization itself. So how did we actually build this system to produce data-driven improvements? Remember our goals. We have the data, and we want to get meaningful insights out of it so we can make business decisions based on the information we actually already have. We need to gather and understand the data, then communicate the results of the analysis to the stakeholders so they can act on it. And the best way to do that is with code. Full disclosure, we love code. Code is repeatable, it is inspectable, and most importantly, it's reusable. With code, you can go in and look how a problem was solved and either adopt it or make changes to make it work for your particular use case. To quote our president, Tarif Kawaf, code is communication, and communication is critical. So we use code written in the R language to solve our problem with the help of some excellent open source packages. For each of the steps in our data science workflow, there are a group of R packages that are particularly suited to the task at hand. These contain functions that make it easier and more effective to write code for a target operation, for the problem that you're actually trying to solve. So let's walk through some code to see how it works, using as an example a simplified version of our customer support ticket data graphs. And I realize that it's very unusual to walk through code in a Keynote, but I want to show you how straightforward it is to take a look at your own data to drive business decisions. You don't need to be a programmer to write code. This is not supposed to be scary. All you need are some good tools and the support of a community like the kind that we have in R. As we walk through the code, we'll keep track of where we are in this process in the lower left-hand corner there. First, the import and tidy steps. We need to get the data into R, and there are a variety of packages available based on what your data source is, from everything from text files to Excel to Google Sheets to SAS to SPSS. Anything you can think of, there's probably a package for it out there. For this application, we're working with APIs, so we will use a pair of packages that are designed to work with HTTP-based calls. So there are a couple of functions that we use to get the data into R and then to parse it out. And then we pull out the information that we want. In this case, we want the tickets. Now, this API happens to be paged, so you'd need to loop through this, but it's pretty straightforward using this same technique. Now that we have the raw data in R, we're going to need to transform it into a shape that we can use. As is the case with many data sources, the Zendesk API responses aren't particularly easy to work with, so we're going to need to transform it a little bit to make it easier to work with later in the process. We need to end up with a data frame that has variables in the columns, observations in the rows, and values in the cells. This makes it a lot easier to analyze, to model, and eventually to visualize as well. So with that goal in mind, we load up the packages we need, and then we transform the data. So in this case, we're using the product field. It's nested several layers down. We need to pull it up and get it into a format that we need, and then bind it, basically smash it into our existing support ticket data. And we'll repeat this with all of our nested fields until we end up with one flat data frame. And now that we have a flat data frame to work with, we can actually start transforming some of the fields. So the API comes back entirely as strings, meaning that they're difficult to work with dates and with factors. So in this example, I have a status column. I'm going to convert it into a factor to make it easier to work with. And the dates, I'm going to change the format, again, to make it easier to work with. And in this case, I'm also pulling out the month so that I can graph against it. We do this for all of the different fields that need to be transformed in some way. The entire goal here is to make it as tidy as possible to make it easier to plot later. Now that we have everything in one tidy data set, it's time to visualize. So I'd like to show you how few lines of code it takes to get from a tidy data set into a beautiful graph that you can share with somebody. Here I'm using the Shiny package for user interaction and the ggviz package for plotting. There are lots of different plotting tools. You don't have to use this one. This is just an example. So I'm not showing it here because I don't have much room on this slide, but the first thing you want to do with with a Shiny application is to filter the data based on user input. So you need to present that input to the user, let them choose what they want, and then filter and transform the data based on that so that you're plotting exactly what they want to see. So, So this next part of here, what we're doing here is we're summarizing the data that we have. We are selecting the columns we want. We're grouping it by week. We're summarizing it. We're counting the entries. And then we're adding a column for the, I'm calling it action, but it's what it's going to be used for the labels on the line graphs. Then we create a plot here using the week as the x-axis, the number of tickets as the y-axis. We add a legend and some axis labels, and with that many lines of code, we've got a data visualization that anybody can really read. This is something that you could actually pass around and work on it. So what we're seeing here is that after our usual lull in the number of support tickets in December, our numbers shot up in January and February. This wasn't visible before. It's visible now. We can say, wow, maybe we should do something about that. Maybe there's something we can do to indicate the number of tickets. But the point is that you couldn't see this before. Nothing in the tools we were using was exposing this for us. And now with a few lines of code, you actually have something you can work with. The next step in the data science process is to model the data. We didn't need to do this for the support ticket data because it was, the application was designed to be descriptive rather than predictive. But as I mentioned before, my colleague Andre created a model to try to predict customer churn and using the packages you see here, Broom, Recipes, and Tidy Models. So once the analysis is in a state we want to communicate the results, there are several ways to disseminate that information. In my previous examples, we used an RStudio Connect server because it makes it so easy to collaborate and disseminate that information. But Connect is built on open source tools like Shiny and R Markdown, and there are other ways to share that information as well. For example, you could use a Shiny server, which has an open source version as well as a commercial version, depending on the features that you need. Or you could deploy your application or report to the Shiny Apps I/O. This is our visualization service in the cloud, with the advantage of you not having to install a server at all. So this is a great way to get started with Shiny. You play around with it a little bit, you throw it up on Shiny Apps I/O, and anybody can get to it at that point. Or for static R Markdown documents, you can knit it or export it into a variety of formats and distribute it manually. Output formats include Microsoft Word, PDF, HTML, or presentations. So you can build slides using formats like Slidey, Beamer, or even Microsoft PowerPoint, and send that out to your stakeholders. But regardless of the output format, the analysis remains reproducible. You can rerun it and see the same results, or you can run it with updated data and be confident that the logic behind it hasn't changed. Or if you want to, you can easily make changes to that code to adapt to your organization's needs and scale the analysis based on your new needs and your new set of data. So to review, we were able to drive product improvements with data analysis by collecting and storing actionable data from the user, pulling it all into one place. In our case, we pulled it into R. Writing scripts that were reproducible, scalable, and measurable, visualizing the results, and then communicating those insights to our stakeholders. The result of this work is improved products, happier customers, and a reusable set of analytic scripts that not only helps us identify usability issues, but can also confirm when they've actually been addressed by the changes we've made. We built all of this with open source R packages. And our success is rooted firmly in the amazing community of our users and contributors who create and nurture these tools. With this approach, it's not only possible, but I would argue advisable, to use the data you already have to affect meaningful change in your organization. It's easy to get started, straightforward to customize, and profoundly impactful to the way that you make business decisions. Doing data science with R is affordable, transparent, and impactful, and I hope I've inspired you to give it a try yourself. Code doesn't have to be intimidating. Simple scripts can be hugely, hugely helpful and useful. And there's a strong and inclusive community here to help you get started. And it's not just us who have found value this way. If you'd like to see how other people have built, visualized, and communicated analyses using their own data, I encourage you to visit the Shiny User Showcase page on our website for some examples that other people have built with the same technology. My contact information is here if you have any questions later, and also please feel free to grab me anywhere later in the conference. I'm always happy to talk your ear off about this topic. So thank you very much.
Thank you so much, Amanda. We do have 5 more prizes that I'm going to announce from the raffle. So UC actually has 5 passes to their conference. I apologize in advance if I butcher your name, but just head back to the tech table to claim the prize. So Amy Nelson, Beth Bushmeyer, Aaron Ham, Preeti Pramadurthy, and Sandra Wingert. So if you're one of those people, head to the back. And then finally, I wanted to take a second and just thank all of the sponsors for sponsoring this event. Hopefully you went to their booth. So if we could just do one more round of applause for the sponsors. And I wanted to take a second also to thank all of the speakers. They've worked really, really, really hard for this conference. So if you see any of the speakers, just thank them for spending a lot of time taking their work off in order to come here and give you guys knowledge and share with you their experiences. I'd also really like to thank Ruth Milligan for being our MC and for also being our speaker coach. So thank you, Ruth. She's behind the stage, so we'll just give her a round of applause. And then if anyone here is from the WIA team, if you could just stand real quick. They might be running around. Just a quick round of applause for the WIA team for putting the conference together. Just a few announcements as well. We are having the AI showcase downstairs. It is included in all of your badges and your tickets, so please feel free to stick around. That's going to be for 2 hours tonight. There's 5 companies down there. They all have demos of their product. So, swing by their table, watch the demo. There's passports in all of your bags. So if you mark off all of the companies on the passport and put it into the box at registration, you could win some of the really great prizes that we have. So we'll announce those at 6:30. If you are missing one of those, you can grab one at registration, and we'll get those for you. One more quick reminder as well, if you didn't use one of your lunch vouchers in your bag, we have a place to put them in at registration, so a basket. So if you could just throw those in there if they're unused, that would be much appreciated. We do have a lot of great content and speakers for tomorrow, so we will see you back here bright and early at 7:30. We'll have breakfast ready for you, waiting, and coffee as well. So thanks so much for coming today.